Guys will write like this. The way it looks so elementary, but there's quite much to it. A negative 3 over x plus 4 is greater than 0. That's an inequality. And then we'll express the answer using interval notation. Does anyone have a clue what you could do to start in an attempt to find what on earth is the answer, and we'll place the answer in interval notation. What is it for this particular inequality? I see your hand going up, yes?
I believe you break it down and you put -3 on both sides.
You can't do that. I understand why you said that. It looks like you could. Cannot do that. Yes?
Maybe we should do, I don't know,
Yep.
-15.
No. Wait till you see what I'm going to do here shortly, and you'll say, you're kidding. Professor, you're kidding. It was that simple? But I want to hear what you guys might think when you first glance at it. Because math, when you first glance at it, may not mean or look the same as it does to me. Yes?
You can't have a 0 in the
I'll
denominator, so separate.
I'll first point that out. She said, Professor, for sure, x cannot be -4. I agree 100%. That's not the complete answer. I may give you half a point partial credit just to show that you recognize that right quickly. X cannot be -4. Tell me more. Yes?
It has to be, so it can't be positive, because if it's positive, then it will be negative on the top, the -3.
Oh, look at this. Now, my student's reading math. Math sometimes is difficult to read. He said, Professor, my goodness, the way it looks, let me use a little common sense. Let me just read what it says. It reads like this. This is a fraction on the left. They want that fraction to come out to be positive. Greater than 0 indicates positive. When on earth is a fraction from middle school positive? One of two cases. When the numerator and denominator both are positive, that's a positive. Is that true, guys? Or if the numerator and denominator are both what? Negatives. That comes out to be a positive. Those are the only two cases where you can get a positive fraction. A positive over a positive or a negative over a negative. And that's exactly what they want. They want a positive. So which of these two cases, based on what you see here, am I talking about here? Is it case 1 or case 2? It's case 2 because I've already forced the top to be negative. So what can you say automatically, like my student was telling me, what can you say automatically just using a little common sense there? What must this down here be to satisfy this?
X plus 4 must be less.
X plus 4 must be negative, written like this, less than 0. And therefore, when you solve it, just go ahead and solve this, move the 4 over, subtract it. Guess what? There's your answer. Now, if I put in interval notation, everything less than -4, in interval notation, guys, we talked about that last week, is that negative infinity up to a -4, not including -4. Is that true? That's your answer. Now, someone in my 4 o'clock session, we saw something like this, and that's one reason I thought I better start up with something like this. They said, Professor, I know it's going to be a little bit more complicated on the test than this. Professor, if you saw this, not this, this, yeah, that's going to be a little bit more challenging. Now, what would you do in a case like that? X squared subtract x is greater than 0, solve for x, place your answer in interval notation on the exam on Wednesday. How would you approach that?
Factor out an x.
Tell me again.
Factor out an x.
Factor out an x. This is more in line with what we were doing last week. And then use what? Sign analysis. And go to a number line and quickly use sign analysis, guys. By this time, we should all know how to use sign analysis. By the way, of all the problems I think on the quiz, the one on the back where I asked you to use sign analysis, you remember that problem on the back of the quiz last Wednesday? That was the one that was correct on more papers. So you guys like this sign analysis. If I use it here, tell me my critical numbers.
1
0.
Well, thank you. And they both in this case are open. And then all you need to do, as we did last week, and this is just a little recap, we tested to see what's going to happen here. The guys out to the left of 0, definitely it's up to you. I'm going to try -2 myself. Between here, 1/2. Out here, 5 maybe. It's up to you. And we'll test right here. I'm going to first replace x by -2. If I replace x by -2, of course, that's a negative there in the front. -2 subtract 1, that's a -3, another negative. And a negative times a negative gives me a positive. Does this indicate I want a positive?
Yes.
So greater than 0 indicates positive. So I have discovered quickly part of the answer. But there it is. In between, let's try it, 1/2. Replace x by 1/2, of course it's positive. 1/2 subtract 1 is a negative result. And a positive times a negative, I'll put it up here, is negative, which I do not want to happen. 5, replace x by 5, positive. 5 subtract 1 is 4, another positive. And definitely those two will give me a positive. And that says yes, based on what you have up here, that's what you want. Everyone agree?
Yes.
So that's more in line with what we were doing last week. Now, interval notation for an answer, a negative infinity up to 0, union what? 1 through infinity. And there's your answer. Now, I'm leaving this, just a little recap, since I haven't seen you for a few days. Okay, I like to see my classes really 5 days a week, 3 hours a day, plus that little hour in between. Now, little recap here. You could have used sign analysis on this one. I just use a little common sense with the help I heard a student help me out. Does anyone see, let me go back to it as I close this down, recap. Does anyone see a way to use sign analysis, which is powerful, even on this exercise? Let's go back to the beginning. Suppose you didn't see this positive over positive, negative over a negative business going on here. Suppose you said, no, Professor, I'm going to jump right into sign analysis. Can anyone tell me if you were using sign analysis, look at this, what's my critical number? -4 is the only thing I have for the x. So -4 is what I'll be working with. Of course, it cannot be included. And right here is sign analysis, even on this problem. Test to the left, try -6. Test to the right, I'm going to try 0. Going back right here, guys, all I have to work with is here. I've got -3 on top. Put a negative sign there for that. If I replace x by -6 plus 4 is a -2. That's another negative. A negative over a negative gives me a positive. Is that what we were looking for here?
Yes.
On the other side, I have to have it works, but we're going to test. I'm going to test 0. Of course, it's still -3 on top. Can't change that. 0 plus 4, positive 4. And this will give me altogether what? Negative? Which I did not want based on that. The one that worked was over here. To the left of -4. And please tell me, is that the same answer as we got earlier? So you could have applied sign analysis to it. Sign analysis is powerful. Guys, any concerns here at all? Now, with that done, just a little recap. Part 2, here's what this lesson, class is all about tonight. Here we go, functions. I think we've done some for functions already. The f of x notation, g of x, h of x notation. I'll just jot down a few of the notations. I had a student who read the definition from a handout way back last week for a function. We did that. Now though, since the exam's coming up, and there were some practice problems on the review I gave you. Let's start out with this. Find the domain. Watch carefully. Of these functions that I plan to list. Let me use f of x for the first one. Now, you guys were with me at 4 o'clock. I had a beautiful one. A student came up to the board at 4 o'clock and worked it out for us. Can you remember what it was? I created it right quickly on the board, and a student came up and you worked it out for us. Who was it?
I think it was me.
Was
What
it?
the square root?
It was a square root. Now, I may not get the same problem here. X squared
Minus x minus 6.
minus 6 minus 2
Minus x.
minus
Minus 6.
x squared minus 6x?
No, it's x squared minus x minus 6.
Oh, minus 6 right here.
Yeah.
Sorry about that. Over what though?
Over x minus 8.
Now, that's a nice problem. That is a wake up. I'm in pre-calc. You're not trying to solve anything. I'm not asking you to solve anything. I'm asking you to tell me what is allowed to replace x with. May I just replace x by any number I wish? No, at random I cannot replace x by 0. If I put a 0 in here, you get 0, 0, you get -6 underneath the square root. You can never let that happen. So there's some numbers you cannot let x be. They want to know, what can you let x be? That's called the domain. Now, the way we did it at 4 o'clock, you guys who are with me, we first did this. And I had students come up to the board and help me out here. This part, for a square root, must be that. In other words, underneath there, it must be greater or equal to 0, or you cannot do a square root on it. You cannot have a negative underneath that square root. That's what this says. And then, of course, it's factors. Now, see, I think I have everything copied down right, do I?
Yes.
Okay. It factors, guys, into that, so you gotta have some factoring skills. And now we're into sign analysis. Right now. We're not quite finished with the problem. Sign analysis says now, if you will finish this up, your critical numbers are -2, +3. At this point, guys, can they be included?
Yes.
Yes, I can darken these in. What saves this one? I gave you what? An equals there. That says those two can be used. And then you start the sign analysis where you choose a number, and you test, and see what works. Now, to save me a little time, we all know how to choose a number and test. Sign analysis. You guys did that on the last quiz. Guys, from the 4 o'clock session, help me out. I think it's to the left of -2 worked.
Yes.
Okay, out here worked. Nice. And I think out to the right of 3 worked.
Yes.
Now, guys, that sign analysis has been used. You can use it yourself to make sure those are the 2 intervals. So that tells me at least this part. But now I've got another part I'm worried about. Down here in the denominator, I cannot let x be what number? 8. So you say, oh, professor, you're not quite finished. You got to show on this diagram to show sign analysis that when you reach 8, and you are going to reach 8 out here, this goes on forever, you got to go out here and show me, hold on, you can't use it. Even though this does go on like this, but you cannot use 8. You guys agree?
Yes.
Now that's the answer. I had to place an interval notation. That's the answer. Those are the allowable x's. You pull an x out any of those red regions, guarantee you, if I take it back and put it in, it'll work. Now, let's put that in interval notation though. For my final domain, guys, this part here is easily written as a negative infinity up to a -2 bracket. Union, this one is, gotta be careful with it, it's written as bracket 3 up to 8, cannot include 8, parenthesis, union 8 through infinity. And there's my domain. Trying to get your mind back into it. You guys follow that? Now, if you can do one like that, you're doing well, super well. Another one that came up at 4 o'clock. I love that 4 o'clock session. You guys have an opportunity to ask questions here. G of x, I had a concern, I think, with something like this. I think it's x squared plus 9. And they want the domain. Don't try to solve it. Why can you replace x by here on square root of x squared plus 9? First thing that came to a student's mind was, and as a student, probably not mine too, you would probably say, Professor, isn't that a perfect square root? Isn't that this? You go to USC and say, oh, I know the square root of x squared plus 9 in that auditorium. And they'll say, what is it? X plus 3? And they'll say, which school did you come from? Don't you say? Because it's not x plus 3. Can anyone give me a reason why square root x squared plus 9 looks like it's screaming x plus 3, x plus 3? Why is it not? Can anyone give me a reason? Why is this not equal to x plus 3? Go for it.
Because x plus 3 squared does not equal x squared plus 9.
For a check, she's exactly right. If you take this, if you think that's the answer and you square it, it should take you back to that. It doesn't. You get this. Doesn't check. But they still want the domain. Well, the domain can be found by, most students will recognize that that part underneath their professor must be this, if it's a square root. Now, what am I allowed to replace x by? Should I use sign analysis? And if you try sign analysis here, guys, I think we'll run into an issue. I don't think in this case sign analysis will work. You guys see the issue? If you try sign analysis with this one, like I did on one before, I don't think you can even use sign analysis. You're going to try and take the square root of a negative. It's impossible. Can someone tell me, and sometimes you got to read math, can someone tell me just by observing this, what on earth can you say about this compared to what I want? What may I replace x by?
Any number,
I heard it.
any number.
Any number. This one says x can be replaced by any number you throw at me. I don't care whether it's positive, negative, 0, pi, square root 2, you put it in there, you do the business, you square it, add 9, you're guaranteed this is always going to be what? Greater than or equal to 0. If anyone in this class can give me a number where I replace x by it and do the business up there, x squared plus 9, and it does not give me a number greater than 0, you're excused. I'll give you the A for the class, and you don't have to come back. You want to think you have a number? A real number, not imaginary. No, you can't do it, so we're all going to be together the rest of the semester. So this tells me, based on what was given to me, it's all real numbers. If I say put it in interval notation, you're saying, oh, Professor, you mean this. And there's my domain. Oh, this test is going to be good. This test is going to be good on Wednesday. Get ready for this one. Okay, so guys, I threw in a few of these, which will be on the exam Wednesday. A few inequalities, also maybe a few equations like you saw in the last quiz. Definitely some of these. We had to find the domain. I think I gave quite a few of those on there, didn't I, on the review. So there's domain, some of those on the test on Wednesday. Now you say, Professor, I looked at the review. I wanted to do well in this class, but I saw other things going on here. Like, I heard a student mention this. Oh no, Professor, I saw some graphs. In my homework, I think you mentioned homework. I saw some graphs and I didn't quite understand how to do it. Now, these are graphs of functions. I'm not going to graph a non-function for you. First, I'll mention a few basic ones that we're responsible for. And if I did what I should have done today for class, which I did. Oh, I did. I'll give you a handout of the graphs that you're going to be held responsible for. They're called parent graphs. So I'll give you a list of this. And I know when I walked in the first day, this guy who is teaching here before I am, leaves the board a mess. I think he teaches calculus.
I think it's business math.
Oh, he's a business math? Anyway, when I looked at the board on the first day when I walked in, he had these drawn on the board. Okay, I have this on the handout. So these are the graphs you're going to be responsible for, and I'll show you what you must do with them. Let me discuss just a few of them though first, guys. These are all functions. If I say f of x equals x, and I better put the word here, sketch. I want to sketch these. Many students would tell me quickly, Professor, I was looking for maybe a straight edge. I sort of know what that function looks like as a graph. Does anyone think they know what f of x equal to x looks like as a graph? Is it a circle? Is it a parabola? Is it a straight line? What is it? Yes.
It's a straight line at a 90-degree angle.
Okay, not 90 degrees.
45 degrees.
No, it's slanted.
Sorry, yeah.
It's slanted. 45 degrees? And does it go through the origin?
Yes.
Does it do this? A slant? Something like this? Yes or no?
Yes.
And that's the graph, should be a straight line there, of y's equal to x. Now, as these become a little tougher to recognize, you can always do a little table on the side there and create some points and plot points. But right now, I think we're okay. B, if I saw this, let's call it g of x. These are all parent graphs. X squared, oh, Professor, no problem on this. What should an x squared, something with an x squared, they ask you to sketch it, what should its sketch look like? Well, in fact, the sketch is a parabola. All the x squareds, quadratics are called, sketch into that. Now, could that open down? It could.
Yeah.
I might open it up, and there's a vertex and so forth and so on, but that's a sketch of a parabola representing a quadratic, x squared. If I go up to, let's call this one h of x, let's go up to x cubed. And one of my colleagues, I was talking to him today, he teaches calculus, and he was telling me he's doing this now in his calc class. Before he gets a chance to actually start calculus. He hasn't started calculus yet. He's still going through some review. X cubed, some students may recognize it as a graph. Anyone describe x cubed? And you could always plot points, like you did back in middle school, and connect the points to get the shape. But does anyone think they know the shape of an x cubed function? Yes?
Like that.
Something like an S, something like this. Has a little curve to it. And does something like that. That's the graph of x cubed. Now I say, Professor, can you go up to x to the fourth? There's a graph for it. I'm not going to show you the x to the fourth. I don't think it's on the handout. X to the fifth, there's a graph for it. X to the sixth, there's a graph for it. So if they give me a function, there's a graph. These are some basic ones. So guys, we've got x, x squared, x cubed. Now, let me pick up next this one. Let's call this j of x. Suppose for some reason you see the need for a graph representing 1 over x. Does anyone recall what its shape is? Is that a circle?
Two curving lines.
There we go.
Two curving lines. Like
Okay, two curving lines. Now let me see what he's describing for me. Let me get this rough sketched up here. He's saying, Professor, I think there's two parts to this graph. We may have to plot some points to find this one for sure. I think he's describing for me there's two pieces to it. Are you telling me that maybe there's one piece up here that looks like that? Yes or no?
Yes.
And another piece down here that might look like this. Yes or no? Woo! Now, I'm just getting the basic graphs out of the way. We're about to finish up the basic ones. By the way, guys, the name for this one is, this is sketching 1 over x. Some textbooks will call this the reciprocal function. One over x. That's the way the reciprocal function looks. There's the cubic function, there's the quadratic function, and there's a simple x. They all have shapes. They all have graphs. Let me think of something else. Yes. Letter E, we come over here. Let's call this n of x. And we'd like to see a graph of this. As those two straight bars, what function is it to begin with? What does that mean before I even sketch it? Yes?
Absolute value.
Absolute value. This is the absolute value function. The absolute value function. Now, does it have a graph? It certainly does. And I don't know how many of my students will recognize it. I'm hoping quite a few will recognize it. If you want to have an idea of what it looks like. And I can always plot points. Yeah, describe it for me.
It's a V.
V-shaped graph. She said, Professor, I think it's a V-shaped graph that might look something like this. Piece here, another piece like that. A V-shaped graph. Absolute value. Wow. I'm thinking about I'm thinking about holding off on this one. In fact, I don't think it's even on the handout. When you finally get a handout. These are some basic graphs. And I said, Professor, where are you going with this? If I know what these basic graphs look like, then shortly, we will have to sketch, not tonight probably, but shortly, we may have to sketch this. Which means it might have something to do with this graph. That's x cubed. But you're adding to it something maybe with this graph. You're doing 2 in 1. X cubed plus x squared. Maybe I can use those two together some way to get x cubed plus x squared together as a function. That's coming up later on. With all that said though, let me make sure we do have what I need here. It's this. Let me go back right quickly and express the domain and the range on each one of these sketches. Okay, the domain and the range on each one of these. All right, guys, the domain on the first one, I'll squeeze that in right there. Can anyone tell me, from left to right, on the x-axis, since I have the graph, and that's what domain's all about, the x's. Tell me, from left to right, how much is this graph covering, stretching, as you go from left to right, the way it looks?
Negative.
Is it going negative infinity that way forever?
Yeah.
And is it going out to the right forever? Written like this. My domain is this. Now the range. The range is not the x's, it's the y's. Let me label this as y here. Now it's the up and down. The y's. Well, how would you describe this graph as the up and down? How far up is it going? I see the arrows. And how far down is it going?
Negative infinity.
Negative infinity through positive infinity again. It's rising and falling forever. Done. Let's go to the parabola for the x squared graph. Its domain, guys, from left to right, and you know this goes forever. But from left to right, as you go on the x-axis, that's what domain is, the x, you're going this way. Describe for me, what does the blue graph cover as you go from left to right? How would you describe what's the domain? Negative infinity through positive infinity. It stretches forever, horizontally. Now the range, of course, the set of y's up here. Now the up and down. Yeah, it drops down to 0. So the range, and it includes 0, bracket. And how far up does it go? How far does it rise? Infinity. It's rising forever. There's the domain, the range on the x squared graph. If I look at the cubic graph, domain, along the x, guys, as I go from left to right, that blue graph, that strange S-shaped graph, looks like what?
Negative infinity.
Is it also negative infinity through positive infinity? Stretches to the left, stretches to the right, forever. Now the up and down, the range, again, it's dropping down and rising forever. That's easily done. Next one, gotta be a little careful with this one. Its domain is,
Negative infinity to 0.
oh, I heard someone say it. What is it again?
Negative infinity to 0.
Hang on, negative infinity up to 0. Tell me more.
And from 0 to.
Thank you. Union, 0 through infinity, absolutely correct. He's leaving out 0. Is that true? I cannot let x be 0. Range,
Same thing.
be careful. The up and down. How far down does this graph drop? Looks like, is it going down forever?
Yeah.
That's the y values are the range, so it looks like it's dropping down forever. So that's a negative infinity.
To 0.
How high up does it go? You say, well, Professor, it also rises forever. But there's a piece in between that separates it. I agree, it does drop forever, and it rises forever. Now, I'm hearing the students say, Professor, there's a piece in between that separates it. You gotta be careful. Now tell me what you want to tell me.
0.
Yeah. Negative infinity, up to, look at this, up to 0, union, 0 through infinity. Do we agree?
Yes.
And there's a range, domain, and range for the reciprocal function of 1 over x. Just some basic functions. That's all it is. That's all we have here. Now, if for some reason, let me check and see. I think we'll finally get this. There's one more I want to point out before I hand this to you. Let me squeeze in one in here. Letter E, I guess. The last one I'll do looks like this. It's called K of x. And it's this. Square root x. I'd like to know, what does that shape look like? And some students may recognize it, some may not. You may have plot points, form a table, and plot points and do it, but does the student think they know the shape of it? We're going to place this on the grid. Any ideas of what a square root x graph looks like? Then we'll list the domain, the range. Yes,
Like this.
I got you. All right, tell me that something like this. A little curve to it. Not a straight line, a little curve to it. It looks like there's a little curve there. That represents a square root of x. Now, if it does, what is its domain based on your graph? The set of x's. Look at the graph and tell me on the x-axis, what's the extent of this graph along the x-axis? From 0 through infinity. Bracket. Now before I get to the range, hang on before I get to the range. Suppose I had asked you to find the domain on this without seeing the graph. Suppose you had not seen the graph, and the same question came up, what's its domain? You'll say, all right, Professor, we talked about this last week, we talked about it tonight. If it's a square root, that part underneath there must be what?
Greater than or equal to.
That. Are we saying the same thing? Now the graph verifies it. That is my domain for sure. Same thing we were talking about last week. Range on this graph, be up and down, be careful. How far down does it drop? And how far up is it implied to go?
0 to 0.
Yeah, it drops down to 0, including 0. And how high up is it implied to go? Infinity. So there's my domain and range on a square root. Now, before I leave this one, the other domain says what? Bracket 0 through infinity. X must be greater than or equal to 0. That makes sense. Now the range, so happens the range came out to be the same thing. Can someone tell me in your own words, what does this range mean based on what you know a square root does? What does this tell me down here, the range, which is the same as the domain's interval, but what does this tell me in terms of this? From middle school. The range is also bracket 0 through infinity. And the range is a set of y's.
The y must be positive.
Tell me more.
Y must be positive.
Y must be positive. Tell me more. Y must be positive. They said, Professor, what are you talking about? If I did this in middle school, if I said square root 25, I've satisfied this. 25 is in my domain. The answer is 5. Is that in this range? So that says when you do a square root, what's coming out for an answer? A positive. Now I know some students, I think on that last quiz, I saw some students, for some problem, I forgot what it was, they were doing this. And that's a no-no. Can someone tell me why is that a no-no? The square root of 25 with that square root symbol is 5 only. You cannot let it be negative 5. Now before you answer, I want a good answer. If you saw this, then yes, I will accept that. Can someone tell me before I close this down? Why? Why is square root 25 not plus or minus 5? Don't you go over to UCLA and say that. Square root 25 is plus or minus 5. No. If you do, tell them you went to LACC or another school, not SMC. Don't mention us. No, you can't use that. So what do why? Why can I not say plus or minus 5 for this? And I saw a student on the last quiz for some reason thinking this. It's only this. Why?
Because the range is
Right there, the range, the answer coming out, we've already verified by the graph. The range must fall between 0 and infinity. And negative 5 is not caught between 0 and infinity. So the graph says no, you can't use it. Okay? Now, those are some basic graphs. Wait till you see what we're about to do with them shortly here. But, you step back and look at it. All this making sense so far? Now, one of my students asked, I got a couple of emails, said, Professor, I'm studying my review for the test and I want to do well. And I said, yes, I want you to do well also. But they said, I saw something, Professor, on the review that we have not done in class yet. If you guys have looked at that review, I think you may know which one they emailed me about. They said, I saw something called difference quotient. Was there something called difference quotient on that review? Please tell me.
Yes.
Was there something called difference quotient, which I had not even mentioned? Last week we got so busy with other stuff. Really, I had not mentioned it. Now I'm gonna show you what that means and how easily calculated it will be. Some examples there. But guys, before I do this, I think that's a good demonstration of some basic graphs to look at. Okay? There could be others, but I think there's enough right there for us right now. Let me erase this and do something with you. I think I have a handout I want you to work on. Let's call this part 4. gonna draw a graph for you. I'll sketch a graph and then show you what I want done to this graph. And let me label this as the x-axis, of course, this is the y-axis. And by the way, we know these are quadrants. We have 4 quadrants. And before I jump in and show my graph, I was just out of curiosity, does anyone recall if you plot a point